Welcome to this video. In this video, we are going to look into the topic differentiation. Differentiation is a part of mathematics called calculus. We can use differentiation to understand the rate at which changes takes place. For example, when you drive a car, your position and your velocity changes with respect to time. Or population growth over a time period, rate at which a virus spreads in a city. To understand differentiation, first you need to understand gradient. I hope you remember gradients and how to find it when two coordinate points are given. Gradient equal to rise over run. Or this can be written as change in y divided by change in x. How are gradients related to rate of change? I hope you remember gradient is about the steepness of a line. That is, it is a way of measuring how fast y changes with respect to change in x. So gradient describes the rate at which changes happens. How to find gradient of a curve using a graph. So look at this graph. Let's know how to find the gradient of a curve using these graphs. The first graph shows the population growth of city A and the curve is a straight line. On this straight line, take any two coordinate points which lie on the straight line. For example, let me take this and join like this. This is change in y and this is the change in x. So for a straight line, the gradient is rise over run, which is nothing but change in y divided by change in x. So this is rise, and from here to here it is the run. So for a straight line, you can choose these two coordinate points anywhere on the line. For a straight line, the gradient is constant. And I hope you remember the equation of a straight line, which is y is equal to mx plus c. Here this m represents the gradient, otherwise known as slope of a straight line. Okay. So in this diagram, the population growth of city B is given. So for a straight line, we know how to find the gradient, but this is a curve. Let's learn how to find gradient for this curve. When you take any 2 points on the curve, the gradient will be different. Suppose if you are taking here and here, the gradient will be negative. Whereas if you take here and here, then the gradient will be positive. So you will get different gradient value at a different point of the curve. So how to find a gradient then? We can find a gradient at a particular point by drawing a tangent to the curve. Because at any point on the curve, the gradient of the curve is equal to the gradient of the tangent at that point. Okay. Suppose you are going to find a gradient at x equal to 2010, you have to draw a tangent like this. This is the tangent. Recall what a tangent to a curve is. A tangent to a curve is a straight line that touches the curve at one point only. So how to find the gradient of the curve? By finding the gradient of the tangent. Let's take any 2 points. I'll take here and here and join like this. Okay. This is the change in y and this is change in x. So we know the gradient is rise over run. So we can calculate by using this. So for this curve, By using this formula, we can calculate the gradient of the curve when x equal to 2010. Similarly, you can calculate for different x value, it will give different gradient value. Drawing a tangent each time is a tedious process, so we are going to use algebra now. Equation of curve can be written as y is equal to f of x. Input and getting y as output. It is possible to create an algebraic function that takes x coordinate as input and giving gradient as output. This algebraic function is known as gradient function or derivative function. The way to represent this gradient function or the derivative function is dy by dx. And this can be written like this also. F dashed of x. If y is equal to f of x, dy by dx equal to f dashed x. The differentiation turns the curve equation into gradient function. So how to do this? We need to follow some rules. Suppose if y is equal to kx power n, then dy by dx is write the constant k and write the power of x, which is n here, then the base, and decrease the power of x by 1. So n minus 1. Suppose if y is equal to kx, so dy by dx will be k. Take the power of x as 1. So here n value will be 1, x power 0. So this is equal to k. When y is equal to the constant k only, then dy by dx is 0. Suppose say y is equal to 2x square. Then what is dy by dx? 2 multiplied by the power of x is 2 multiplied by x power 2 minus 1. So 4x. Suppose y is equal to 3x. So dy by dx is just 3. When y is equal to the constant, suppose y is equal to 4, then dy by dx is 0. Suppose y is equal to 2x square plus 3x plus 4, then what is dy by dx? Equal to 2 multiplied by 2 is 4x plus 3.
Now, when we get a
Gradient function or a derivative function of a curve, then from this how to find the gradient? Substitute the x coordinate into the gradient function to find the gradient of the curve at that point. Now let's look at this example. Find the gradient of the curve y is equal to x square plus 4x plus 5 at the point 1, 2. For this, first we need to find the derivative, that is the gradient function dy by dx, which is 2x plus 4. Okay, so we need to find the gradient of the curve at the point 1, 2. In the point 1, 2, x is 1. So dy by dx at 1, 2 is 2 multiplied by 1 plus 4, which is equal to 6. So the gradient is 6. Next, a turning point of a curve is a point where the graph changes the direction from increasing to decreasing or from decreasing to increasing. In simple terms, we can say it's where the curve turns. The gradient or the slope at that point is 0. It is otherwise known as stationary point also. A turning point occurs where the first derivative is 0. That is f dash of x or dy by dx is 0. Here y is equal to x square minus 4x plus 3. So dy by dx is 2x minus 4, and we have to equate this to 0 to find the turning point. 2x minus 4 is equal to 0. Solving this, we get the x value as 2. So when x equal to 2, y is equal to negative 1. The turning point is 2 comma negative 1, which is nothing but the vertex. There are two types of turning points. Maximum turning point occurs when the curve goes up, reaches a highest point locally, then goes down. Next, minimum turning point, which occurs when the curve goes down, reaches a lowest point locally, and then goes up. So how to find whether the turning point is a maximum or a minimum? By using the second derivative. The second derivative tells you the type f double dash of x, that is d square y by dx square. When this is less than 0, then the turning point is maximum. When d square y by dx square is greater than 0, then the turning point is minimum. Let's solve this question. Find the coordinates of the turning points of a graph of y is equal to x cube minus 12x plus 6. You must show all your working. First, we need to find the turning points. So to find the turning point, first step is to find dy by dx. Okay. So dy by dx is 3x square minus 12 and equate this to 0. So this is equal to 0. 3x square is equal to 12 or x square equal to 4. So x is plus or minus 2. When x is plus 2, y is 2 cube minus 12 times 2 plus 6, which gives negative 10. And when x equal to negative 2, y is equal to minus 2 the whole power 3 minus 12 times minus 2 plus 6, which gives 22. So the turning points are 2 comma minus 10 and negative 2 comma 22. Determine whether each turning point is a maximum or a minimum. Show how you decide. To solve this, first we need to find d square y by dx square. Okay. So dy by dx is 3x square minus 12. Now when you differentiate this one, again you get 3 times 2, which is 6, 6x. So d square y by dx square is 6x. Now substitute the turning points one by one. So first let's substitute 2 comma negative 10. When x is 2, 6x will become 12, which is greater than 0. So the turning point is minimum. And let's substitute the next turning point, negative 2 comma 22. When you substitute x value as negative 2, d square y by dx square is minus 12, which is less than 0. So at this turning point, it is maximum.